and welcome everyone. This is Laura Podolsky with the National Center for Sustainable Transportation. Just so everyone knows they're in the right place, this webinar is Reducing the Carbon Footprint of Freight Movement Through Eco-Driving. Today's webinar is brought to you by the Policy Institute for Energy, Environment, and the Economy at UC Davis and the National Center for Sustainable Transportation. The National Center is one of 5 national centers designated by the U.S. Department of Transportation as a part of their University Transportation Centers program. Our mission is to advance a more sustainable transportation system through cutting-edge research, direct policy engagement, and education of our future leaders. Our consortium is being led by the Institute of Transportation Studies at UC Davis in partnership with the University of California at Riverside, University of Southern California, California State University at Long Beach, University of Vermont, and Georgia Tech. We're very pleased today to be hosting today's webinar. This webinar is a part of a rollout of a white paper from the National Center for Sustainable Transportation, authored by our presenter today. The white paper and associated policy brief can be found on our center's webpage, and it can also be found on the event website for today's webinar. For today's webinar, we will spend the first half hearing from our speaker and featured guest respondent, Tyler Cooley. The second half of the webinar will be dedicated to Q&A with all of you, so we hope you all came with questions. As you can probably tell, everyone is on mute. This is to ensure that we will not be disrupted by anyone that can't find their mute button on their phone. So we do not want to hear any dogs barking and phones ringing while our speakers and guest respondents are presenting. So if you do have questions, which again we hope you do because we're saving plenty of time for that, please enter them in the chat box that's in the lower left hand of your screen. You can also use this chat box to communicate with us if you're running into any technical issues, and we'll do our best to try to help you. Also, as a reminder, this webinar is being recorded, and we'll post that on our event page for later viewing. So without further ado, I'm pleased to introduce our speakers and special guest respondent for today's webinar. So our speaker is Kanok Boriboonsomsin from the University of California at Riverside. He is an assistant research engineer at the Center for Environmental Research and Technology at UC Riverside. His research interests include the relationship of land use and transportation to energy and air quality, transportation planning, vehicle emissions modeling, traffic simulation, geographic information system applications in transportation, and intelligent transportation system technology. We are also very excited to be joined by Tyler Cooley as our special guest respondent for today. Tyler is the trucking sector lead for the West Coast Collaborative at U.S. Environmental Protection Agency Region 9. The West Coast Collaborative is a public-private partnership administered by EPA to reduce emissions from heavy-duty fleets operating in the western U.S. by supporting the adoption of emission control strategies through funding and technical assistance to fleet owners. Prior to coming to Region 9, Tyler worked in EPA's Office of Transportation and Air Quality, where he assisted with the implementation of the Diesel Emissions Reduction Act funding program. So as you can tell, we have a great speaker, great special respondent. So without further ado, I'd like to turn things over to our speaker today, Kanok.
Thank you, Laura, and hello, everyone. Thank you for calling in today to listen to this webinar. And I will start off with the presentation outline. We will talk about the background information about why we want to look at eco-driving for heavy-duty trucks. And then I will go over eco-driving practices for trucks. And after that, we will look at the effectiveness and elements of successful truck eco-driving programs, what are included. And then we will touch on challenges and barriers in implementing these programs and discuss research needs going forward. And I will conclude my presentation by summarizing the findings and providing recommendations. Okay, so nowadays, trucking and freight is part of our everyday life. And for a trucking company or a typical trucker, the fuel cost is one of the major costs of their operation costs, accounting for about 30 to 40%. So they have great incentive in trying to reduce fuel consumption from their operation in order to improve their business bottom line. In the meantime, from the government perspective, trucks, especially medium and heavy-duty trucks that are used mainly for freight movement, account for 22% of the greenhouse gas emission from transportation sources. This is roughly about 6% of the total U.S. greenhouse gas emissions. So it's obvious to see that curbing emissions from these vehicles will help our nation meet the greenhouse gas goal that we have set. So these are some example efforts that have been implemented by the government in order to improve fleet fuel efficiency of heavy-duty trucks. NHTSA and EPA have enacted greenhouse gas and fuel efficiency standards for trucks back in 2011, and early this week, the new updated proposed rulemaking was just released for the truck model year 2018 and onward. EPA also has a Smart Way program that try to promote different practices in order to improve fuel efficiency of the fleet. And the DOE also has a super truck program that try to invest in research to develop trucks that will greatly improve fuel efficiency on the road. Now, these efforts are focused mainly on the vehicles, including the tractors, the engine, as well as the trailer, and some of them will take several years before we start seeing the benefits or the impacts. So in the meantime, it's important to recognize that a truck's fuel efficiency has, it depends on how it is operated. And that has a lot to do with the person behind the wheel, which is the driver. So on this slide, we break down the reasons for the fuel waste in a typical trucking operation. So speeding obviously increased fuel consumption because of the less aerodynamic shape of the trucks compared to cars. So whenever a trucks go over 55 miles per hour, that the efficiency drops significantly. Hard acceleration and braking, these behaviors are known to waste fuel unnecessarily. The same is true with idling. And hard turns also contribute to fuel waste in truck as well. So with that, then a lot of people have talked about eco-driving. You might have heard about this term before when the fuel price was very high back several years. By definition of Oxford dictionaries, eco-driving is the practice of driving in such a way that minimizes fuel consumption and the emission of carbon dioxide. To this definition, that eco-driving should always not compromise the safety of oneself and other road users as well. And that's because sometimes people try to adopt eco-driving practice and to the extreme that it could be unsafe to others. And if that causes accident, then it doesn't worth it. Now, in a broader sense, eco-driving can be expanded to include non-driving activities such as pre-trip planning of route and schedule, as well as vehicle maintenance. Typically, the core principles of eco-driving are very similar across different vehicle types. but there are some tips that are specific to heavy-duty trucks because of their unique aspect of engine. In the next few slides, I will talk about some of the key tips, eco-driving tips for heavy-duty trucks. Starting off with pre-trip planning, it's a good idea to plan the route and schedule before you take the trip. Obviously, try to avoid winding roads or hilly routes or mountainous terrain. And if possible, check the weather ahead of time and try to stay away from bad weather such as heavy snow and strong headwind and even crosswind. All these factors adversely impact the efficiency of the trucks. In terms of schedule, try to organize the pickup and delivery schedule in a sequence that makes sense, not doing forward and back. And then for truck, because of the driving, the in-service hour regulation, truck must take a rest every 10 hours or so. So it's a good idea to plan that rest during the time when temperature is mild, so that the truck driver doesn't have to turn on the engine for heating and cooling. And while driving, before even start taking off, to turn on the engine is better done at zero throttle. And then the truck should be warm up and cool down per the owner manuals. And in using the gear, truck has sophisticated gear or transmission system. So to save fuel, it's a good idea to apply what is called progressive shifting, and then use double clutching technique, which is to apply the clutch, move the gear into neutral, and then apply a clutch again before changing to the new gear. And as we previously noted, speeding is a major factor in wasting fuel. So try to use moderate highway speeds around speed limit, and then if possible, try to maintain constant speed as much as possible. And while in traffic, it's good to anticipate traffic ahead so that you can accelerate and brake mildly instead of abruptly. And lastly, avoid unnecessary idle as much as possible. In terms of vehicle maintenance, the no-brainer is to have the truck engine service at regular intervals, changing oil, changing air filters, and then have tires properly inflated. And then, but aside from these typical preventive routines, the truck engine can also be tuned in order to improve their efficiency, and also it can be retrofit with different kind of fuel-saving technologies. For example, in this picture, it shows the auxiliary power unit that can help reduce the amount of engine idle time by providing electrical power to heat or cool the cab while the truck is not in use. Now, these are just example tips for eco-driving for heavy-duty trucks. For a full list of tips, please go to the website and then download the white paper. Now we're going to look into effectiveness of the truck eco-driving programs. There have been limited number of studies in Europe, Asia, Australia, and North America. And based on the studies that I have reviewed, the reported improvements in fuel economy vary greatly from 5% to up to 40%. But when I look down closely at each study and focusing on a large-scale study with more than 300 drivers, the reported fuel efficiency improvement is narrower. It's about only 5 to 15%, which is more reasonable. And these results depends on a number of factors. For example, number of truck driver samples that involved in the study, and obviously the baseline driving of these drivers before they receive eco-driving intervention. A good driver will have less room for improvement than a really bad driver. The method of eco-driving intervention also play a role, whether it's a classroom or on-road one-on-one coaching. It definitely has an impact. The setting for the evaluation of the improvement also is a key factor. Some studies evaluate the improvement in the similar environment. Some are based on real-world driving, and these play a role in how the results come out. And lastly, whether the study involves any provision of incentives also has a big role. We will look at this study in more detail in the next slide. This table looks a little busy, but it's one snapshot of all the studies that were reviewed, and it tabulates. Right now it's sorted by year of the study, but what I'd like to bring to your attention is if you look at the field improvement, like I said before, it's anywhere from about 5% up to 40%. But if we just focus on the study with red text, which represents studies with large number of drivers involved, the improvement is about 5% up to 15%. So we probably can speculate that, for example, this study that show great improvement in fuel efficiency might have to do with the number of drivers, or because it's just within the cross driving course without other traffic, so it doesn't represent real world driving. Now, another important point to look at is the latest study that was done in the U.S. So in this study, besides the typical intervention of providing class and feedback to the driver, it also includes financial incentive to the drivers. And with that financial incentive, the fuel economy improvement roughly double. For example, for sleeper cab, without financial incentive, the improvement is 2.6%, but with financial incentive, that number goes up to 5.4%. The same is true for the day cabs trucks, from 5.2% to almost 10%. So it's important to understand how the different eco-driving intervention and even financial incentive may affect the expected result of fuel economy improvement. Now, we know that eco-driving programs for trucks could potentially improve efficiency by 5 to 15%. So we're going to drill down in more detail about the different elements of truck eco-driving programs. What makes a successful truck eco-driving program? The first element is driver education and training, and this is very important because, like we discussed before, a lot of it has to do with the driver. So in terms of education, it can be very broad, for example, by doing awareness campaigns on the different type of media, or it can be a course or seminar format in either classroom or online setting. And these education activities can be supplemented by specific training, either on-road through one-on-one coaching like this, or using driving simulator. This is just to enrich the education or the knowledge that the truck drivers gain with actual experience. And this is a good example of infographic about eco-driving tips. These I download from online, and it can be printed and distributed to truck drivers, or it can be distributed to the different truck fleets, or have it readily available in any truck shops. And it would be a good starting point for educating truck drivers about how they can save fuel from their driving. The second element of a truck eco-driving program is vehicle maintenance and technology support. Because vehicle maintenance is one of the vehicle maintenance has to do a lot with eco-driving. So, for example, by providing free access to air pumps for tire inflation at rest area can help truck drivers maintain appropriate tire pressure. And then any program that can accelerate the availability, adoption, and market penetration of fuel-saving technology would also be helpful. These first two bullets are more from the government perspective, and then from the trucking fleet perspective, it's a good idea to streamline preventive maintenance routines, and that is easily done in a fleet setting compared to independent truck drivers. And then, if possible, invest in any fuel-saving technologies to help truck drivers in the fleet to better achieve eco-driving practice goals. And the last element of a successful truck eco-driving program is policy support. Again, the different policy support are grouped by government. The first four bullets are for government perspective, and then the bottom ones are from truck fleet perspective. For government, any agencies can conduct eco-driving educational campaigns, and the government can also include or incorporate eco-driving as part of the commercial driver's licensing process. Financial subsidies can be provided for retrofitting trucks with fuel-saving technologies, or it can go as far as encouraging or even mandating eco-driving technologies in new model year trucks. From fleet perspective, fleet manager can try to build culture of fuel-efficient driving within the company and include eco-driving metrics in driver performance review. And as we discussed before, recognize or reward truck drivers for embracing eco-driving. Now, what are some of the challenges and barriers for implementing truck eco-driving programs for trucks? Starting off with the driver. The drivers, obviously, especially those professional drivers that have been driving for a long time, they have their own driving habits, and those are sometimes hard to break, right? And even if we are successful in changing their driving habits, it's also a different challenge altogether to try to sustain those good driving habits in the long term. There has been study that suggests that eco-driving performance could fade over time without proper incentive or reinforcement mechanisms. And these can be done through, again, financial reward schemes based on the driving performance or the amount of fuel saved by the driver, or by using onboard driving feedback system coupled with telematic system that continually monitor the driver and their performance over time. For the industry itself, truck drivers are very hard to find. So industry also recognize that it has high turnover rates of drivers. So this sometimes make companies reluctant to invest in eco-driving training and technology because once they invest and the truck drivers leave, then that investment is essentially wasted. And trucking companies, in addition to fuel efficiency, they also have other goals to meet, for example, productivity and safety. So they need to balance among these goals. And probably most importantly, the fuel prices, because the fuel price dictates internal rate of return on any eco-driving investment. So back a few years ago, when diesel fuel price were about $4 a gallon, then there is a strong incentive for truck companies and drivers to try to do anything that will cut down fuel costs. But if the price goes down to $3 per gallon or less, then that incentive is not as strong as before. And sometimes it can be hard to justify any investment on fuel-saving technologies or practices. Government perspective, there are a few challenges and barriers as well. For example, to incorporate eco-driving training or even exam as part of the commercial driver's licensing process, it would involve substantial institutional change by government agencies. And to include eco-driving technology in new modern year trucks through mandates that would require working closely with truck manufacturers and other stakeholders. And of course, funding is always the issue. Without any funding, then it's not possible to conduct any educational campaigns or providing financial subsidies for truck retrofits. Now, we're going to look at research needs that are related to truck eco-driving. As we already realized, truck eco-driving campaigns or programs can save fuel and in turn reduce greenhouse gas emissions. But these programs may also produce significant emission benefit as well. And by emission, I refer to criteria pollutant emissions, especially NOx and PM that are coming from trucks. So the question is how much criteria pollutant emissions can also be reduced by implementing these programs. Aside from emission co-benefits, safety co-benefits are also possible. A lot of the eco-driving practices that we talk about align with safety or defensive driving for the truck drivers anyway. So the question is there any positive correlation between eco-driving and safe driving? And if so, how strong? But on the other hand, when we apply driving feedback on the vehicle, will there be any potential for driver distraction? So that's another safety-related question as well. The next topic of research needs has to do with the impact of truck eco-driving on traffic flow. So nowadays, with the amount of truck drivers that adopt eco-driving practice being low, the impact may not be so significant. But looking forward into the future, if there is a large-scale adoption of these practices, will there be any impact on roadway capacity and traffic flow in general? Because some of the driving practices may unintentionally reduce amount of trucks and cars that can pass through each section of roadway, and that could increase travel time, fuel consumption, and emission of the entire traffic system. So it's very important that we evaluate any potential unintended consequences ahead of time and come up with any strategy if that is really the case. Another research need is on the truck eco-driving technologies. So now there are some onboard devices and instrumentation already available, but these technologies can be brought to the next level by customizing the type of feedback that is provided to the truck drivers. And also with truck drivers already overwhelmed with a variety of devices and systems on the truck, it will be a good idea to develop a new instrument panel that seamlessly integrated all the different systems in a way that will not overload the truck drivers. From the technology side, there is emerging connected vehicles technology that allow vehicle to communicate with another vehicle and also to the infrastructure such as traffic signal. So these new technologies can enable new applications for trucks that will save fuel and reduce emissions. So research is needed to develop these applications that can be very useful. And lastly, with the policies to support truck eco-driving programs that we talk about, the research is needed to conduct policy impact analysis from sustainability, economic, political, and institutional perspective in order to ensure that if policy is implemented, there will be substantial benefit. This slide shows some of examples of ongoing research that I am involved. So these include truck eco-routing. So basically it's a navigation that find the most fuel efficient route for a truck based on its engine characteristic and real-time traffic and topology of the roadway. And then there is research on real-time speed advice, basically providing speed advice to the driver in real time based on traffic condition ahead of the truck or based on the information from the traffic signal. Talking of traffic signal, there is research about freight signal priority, which is similar to transit signal priority that is in use nowadays. Basically, it gives priority to freight vehicles to pass through the intersection because these vehicles, as we know, that consume large amount of energy and produce large amount of emission. So it's better to have them idle less. And then last ongoing research is the eco-driving traffic simulation. Try to simulate eco-driving behavior in traffic simulation environment and look at the different impact on travel time and overall traffic energy consumption and emissions. So to summarize the key findings from this white paper, it seems that truck eco-driving is a win-win-win strategy for the driver, the industry, and government. So everyone has benefit, can be benefit from truck eco-driving programs. And based on large-scale studies so far, these programs can save fuel and reduce greenhouse gas emissions in the range of 5% to 15%. And there are three elements to a successful truck eco-driving program that include driver education and training, vehicle maintenance and technology support, and policy support. And a concerted effort to implement these three elements are crucial to the successful of the program. In terms of recommendation, the first one is to increase efforts in promoting eco-driving as a strategy to improve fuel efficiency and reduce greenhouse gas emissions from trucking operations. And this is aligned with the recommendation by the International Energy Agency. And these efforts can be in the form of educational campaign, financial subsidies, or any public policy that we discussed earlier. And also, another recommendation is to invest in research in order to improve our understanding of the benefit and impact of these programs, and also to further advance truck driving, eco-driving technologies. And that is the conclusion of the presentation. Thank you.
Thank you, Kanok. So this is Laura Podolsky again, and I'm really interested to hear from Tyler. If there was an exciting time for fuel efficiency for medium and heavy duty trucks, now seems like the time with phase 2 greenhouse gas emission standards and fuel efficiency standards coming out for medium heavy duty engines and vehicles. I know EPA is involved in that. So Tyler, I'm really curious to hear from you, kind of your comments and reaction to some of the information Kanok presented.
Great. Thanks, Laura, and thanks, Kanok, for giving us an overview of your findings. I think there's a lot here, and I'm glad to see that you're delving deeper into some of these areas. This information is relevant to our efforts at EPA through the West Coast Collaborative, in that we're trying to reduce emissions from both criteria pollutants and greenhouse gases from the legacy fleet of diesel engines. Even a relatively modest fuel or greenhouse gas emission reduction of 5% can make a huge impact when considering the size of the trucking industry and how long diesel engines can last. That's not to mention the value of the reduced fuel use for truck owners and fleets, many of which are operating on some pretty thin margins in a highly competitive market. Many of these eco-driving strategies, I think, Laura, as you mentioned, can lead to new technologies and are later incorporated into EPA standards. Several of the technologies that Kanok mentioned have been promoted for years through EPA's SmartWay program and its National Clean Diesel campaign. And now we're starting to see some of these technologies that support eco-driving show up in the proposed Phase 2 emission standards for heavy-duty vehicles that was just announced last week. For example, proposed trailer standards rely on technologies like aerodynamic devices, automatic tire inflation systems, and lightweight components. A few thoughts on value of this and similar research and white papers to policymakers and agencies like EPA. First off, I know I depend on research like this to gain insight about what's working and ideas about what government can do to encourage further emission reductions. For agencies like EPA with limited public resources to address truck emissions, this kind of research helps inform where we should target those resources for things like technology demonstration or verification efforts, as well as our incentive funding programs, just so we can make sure to get the biggest bang for our buck. The results of this paper and further research on this topic could also be helpful in making the business case to fleets to incorporate some of these strategies in their operations. So as a researcher, I would ask that you keep in mind what things you see as clear winners for reducing emissions, and what are the compelling messages that could potentially convince some fleets or truck owners to adopt some of these strategies. While, as you said, being mindful that this type of cell could be harder to make in a time of relatively low fuel prices like we're experiencing now. And I'm also happy to see, under your ideas for further research that looking at the co-benefits of how some of these eco-driving strategies can reduce emissions of criteria pollutants. I think this is important from the standpoint of EPA's focus on public health. And given the contribution that heavy-duty trucks make to California and national air quality issues, any information on reductions in particulate matter or NOx could really strengthen the case for supporting eco-driving strategies. Let's see. As Kanok mentioned, mechanisms for ensuring long-term engagement in eco-driving behavior are needed to ensure that these strategies continue to produce the fuel saving and greenhouse gas benefits that we're looking for. Over the long term, knowing how these fuel saving strategies are used can provide a guide for researchers and manufacturers to find ways to quote unquote engineer out inefficiencies from newer trucks. As an example, in some of the battery electric delivery vehicle projects that EPA has funded, we've seen a large variance in the vehicle range of those vehicles, or driving range of those vehicles. A major factor for this variance, I think, is driver behavior. Some drivers modify the way they drive to maximize that vehicle range, while others do not. And while it would be great for more drivers to focus on driving efficiently, we often receive feedback that it's not always a priority for drivers, or in fact for the fleets or companies in general, especially when they're operating on tight delivery schedules and in high traffic areas. So in these cases, I think it's great if there's any recommendations for manufacturers or for ways that they can modify their vehicles to make sure that vehicles perform more consistently regardless of the driver. I think it gives additional assurance that emission reductions are occurring and are lasting. So yeah, I think a good example that some of how this could be done through some of the things you're looking at, Kanok, is have you seen any research or reviewed anything that's shown what the long-term effectiveness is of some of these strategies, such as maybe real-time fuel efficiency information for drivers, and how does that affect driver behavior over the long term? And lastly, I think hearing from researchers about how government can better support their efforts and support additional specific research needs through programs like the National Center for Sustainable Transportation is always helpful. It's just more feedback hopefully leads to improvement in those programs as we move forward through new funding opportunities.
Great, thank you, Tyler. And I'm taking one of your comments as a question that we might throw out to Kanok first. I heard a couple things that I would be really interested in hearing Kanok respond to. One thing you mentioned, Tyler, was providing the economic case for some of these technologies. And so to you, Kanok, and when you were reviewing the literature on eco-driving for heavy-duty vehicles, did you see any type of research or breakdown on the different cost-benefit of these technologies?
Yes, some of the research or studies, especially from technology developers, always make economic case to the fleet so that it can be more appealing. But everything is mostly revolved around fuel prices. So the fuel price is always a major assumption. And but some of these technologies are relatively cheap, in the order of thousands dollars, so hundreds of thousands. So it can be easily invested, and then the benefit can be paid off. The investment can be paid off in a few years.
Okay, so there is some research out there showing, so if a manufacturer adopt this technology over this one, this is the cost, and this would be the payback period for adopting that specific technology.
That's right.
So something else that Tyler posed is if there's any research on the long-term effectiveness of these strategies, and if so, what kind of, from a manufacturer's point of view for truck operators, what should they be thinking about as far as how do they instill this behavior change among their truck drivers over a long period?
Yes. So to answer that question, I'd like to maybe bring up one good example of one fleet that I found. So this fleet provides financial incentive scheme to the drivers, and that tied to the amount of fuel that they save. So basically, with that scheme, truck drivers in the fleet have motivation to drive in a more fuel efficient manner, because if I remember correctly, it was claimed that some drivers can earn additional maybe up to $1,000 per quarter, and that's a lot of money for truck drivers. And that type of incentive also kind of more robust to fluctuating fuel prices, because it depends on the amount of fuel they save, and then the reward tied to the fuel prices.
Great. So I'm going to get to a question that we have from our audience, and this also builds off a point that Tyler made too, and something you said, Tyler, was what are ways that or strategies or technologies where you get that fuel efficiency regardless of the driver and what they're doing. And so a question from our audience was, elaborating, on that. So how does automation play into the evolution of eco-driving?
That's a good question. So it will just make eco-driving much more easier and more effective. So there has been research in connected vehicle that focus mainly on environmental benefits. It is called the ARIS program of the US DOT. And some of the applications that were investigated in that program have to do with trucks. For example, I mentioned freight signal priorities. That is part of the program as well. And aside from that, there have been many studies looking at truck platooning, cooperative adaptive cruise control, and things like that can benefit greatly from automation improvement.
And this is another question we received from our audience too, building on this automation. Are there some, and again, in your review of the research out there, are there some strategies that you saw were more effective than others, or a combination? And this specific question that they had, one of our participants, is, are these automated systems better than training? Or, and looking beyond that, were there other strategies that seemed to be more effective than others?
It's hard to tell unless the automation takes over the driver completely. The driver still has a role to play, and it's always a good idea to have a good driver behind the wheel, whether or not there is automation supplementary to the driver or not. But in the early phases, I think the automation system will kind of supplement the drivers rather than take over the drivers. So the driver is still play a major role.
Okay, great. Let's move to another question we received. So this question is pertaining to, it sounds like the larger context that some of this research is in. So are there certain times of the year, such as Christmas, when truck traffic increases significantly? Will research take into account these periods and possible economic impact of adjusted delivery time?
It's not specified in any of the research that I have reviewed, but I would think the research is focused on the typical operation time, and the Christmas period would be a special case. But having said that, a lot of eco-driving techniques can be applied all year round. Obviously, during the Christmas period, the delivery schedule might be tighter, so there is some trade-off to consider.
And another question along this too is as truck operators and drivers are using more technology to help them with their routing, and something else that you mentioned too, Kanok, was using this technology and thinking about how eco-driving impacts traffic flow and congestion. So how will these new technologies, or have you seen research on this, looking at how the interaction of truck drivers with these new technologies and on traffic congestion? So for example, an independent truck driver pulls over to use one of their applications to optimize their load along the route.
Yeah, it's a very important question. With any new technologies, there's always potential for something unexpected and new behaviors. The example that was asked about, which is independent truck drivers use app to optimize their load along the routes. That's something that has not been studied and not anticipated earlier. But as one of the things that I point out in the research needs, before we deploy any technologies, there should be research done on any potential unintended consequences. In the slide, I mentioned driver distraction, but this type of modified behavior induced by the technology is also of importance as well.
Great. So Tyler, I might turn it to you again to respond to some of the policy recommendations that Kanok recommended. As someone working in EPA, I'm very curious, how do you see those types of recommendations playing out? Do any of them seem more plausible than others? And I might switch here to, I believe it was slide 25 that provides some of these policy recommendations.
Sure, I can try and address a few of those. I think education and sharing information is really important. So making as we talked about a little bit earlier, the business case to fleets and why they might want to employ some of these strategies can be really useful. I know that the SmartWay program is constantly using targeted messaging to fleets to talk about why things like low resistance rolling tires, always win in a cost benefit analysis. The increased cost of the tires will be recouped from the fuel savings faster than a lot of fleets, I think, anticipate. In terms of driver behavior, we as a federal agency can share that information, but in terms of incorporating it into licensing or driver certification programs, I think that's more of a state and local or even a larger fleet policy effort that can take place. In terms of providing funding, I understand, there's a desire to kind of help fleets make that initial investment so that they can start realizing some of those savings from fuel reductions. I think given the relatively small amount of funding that we have to address emissions from the existing fleet, I think that there's been, at least at the federal level, and I've seen it somewhat at the state level too, a shift away from maybe those technologies where there's a clear business case for adopting some of these technologies that do save fuel, just because there's limited public resources to incentivize adopting these technologies, and really we're trying to focus on what are those strategies that can reduce emissions from the dirtiest engines that affect the most people, and often I think we're trying to look at those strategies that control PM and NOx fairly significantly. So it's something like a diesel particulate filter on a piece of construction equipment can reduce particulate matter by 90%. That makes a pretty compelling case for using those incentive funds there. So it's not that we're uninterested or we don't want to see more of these fuel-saving technologies. I think, though, there's not quite as much of a need to incentivize those strategies as there is for maybe some of the exhaust control retrofits. I don't see the policy recommendations in front of me, so I'm just going off the top of my head here. But if there were other ones to address, I can talk about those.
No, that's great. I didn't realize you were not in front of the computer, so me putting up slide 25 didn't help as much for you. So, but this is really great, Tyler, and I think having you participate in this webinar, and you're also a reviewer of Kanok's white paper that is now posted on the National Center for Sustainable Transportation's webpage. It is also posted on the event website. And having your input, participation in this webinar, and really discussing how do we put this research into action. And I appreciate your comment too of hearing from research and the value that it provides to you as a government and working in government and trying to figure out where do we invest our limited dollars and how do we get the biggest bang for our buck. I think all of those comments are really on point, and I appreciate that perspective and having you engaged in this way. So we are getting towards the end of our webinar, and I do want to see, Kanok, do you have any last minute things or not last minute, but closing thoughts, if you will, to share with our group today? You did talk about some of your research. You are doing another research project for the National Center on environmental friendly driving feedback systems. Is that correct? Is there any insights you can provide or teasers that you can provide on where that research is and when that will be coming out?
That research is still ongoing and should be completed by the end of the year. And yeah, when it's completed, I believe the research report will also be posted online on the NCST website.
Great. So it sounds like we'll be maybe having another webinar too. We can share more of your findings. So with that, I'm going to close today. Please look for in your email and your inboxes. We're going to send out a follow-up. It will include links to today's presentation, Kanok's white paper, and policy brief. It will also include a request to take a very short evaluation survey. Your feedback is very important to us in improving our webinars. And please join us for our next webinar. It will be on eco-driving as well. It will be on July 30th. and this webinar is going to be focusing on eco-driving research on passenger vehicles. And we also did have a webinar scheduled on July 16th for eco-driving for transit vehicles. That is being rescheduled, and I will send out more information on that. So this concludes our webinar today, and again, I would like to share a special appreciation to Kanok and Tyler for joining us, and I hope all of you will join us for our next webinar. Thank you so much.